solving a more involved trigonometric equation. So in this case, we have the trig equation 2 multiplied by the quantity tangent of x plus 3 equals 5 plus tangent of x. And we want to get all the solutions on this interval between 0 and 2 pi. So it does look more complicated than some of these other trig equations. What I would suggest you do, if you're not comfortable solving this down and getting tangent on one side by itself initially, is write this out. So it looks like a very similar equation. By using, instead of tangent of x, let's go ahead and just use, say, a w in tangent spot. Nothing special about the w or why I picked that out. I just said to myself, let's pick some variable that's going to replace our tangent of x in both these spots. And let's see if we can solve this down for w. It's going to be basically the same work to solve our original equation down for tangent. So first thing I would do on our side equation here is go ahead and distribute our 2. So we can say that's 2w plus 6 equals 5 plus w. Next thing I would probably do is go ahead and get all of the w's on the same side. This is a nice linear equation, so I'm going to move this w from the right-hand side over to the left side by subtracting it. So 2 w's minus a w makes 1 w. Bring down the plus 6 is equal to 5. And then w minus w is going to make 0 w's over on the right-hand side. Next thing I'll do is to isolate w, I'm going to move the 6 over to the right-hand side. So subtract 6. Once on the left side, once on the right side. 6 minus 6 makes 0 over on the left side. 5 minus 6 makes -1 on the right side. Now back to our equation. We had 2 tangent of x plus 3 equals 5 plus tangent of x. So very, very similar as far as our steps go. If I were approaching this equation, I would distribute the 2. So 2 tangent of x plus 6 equals 5 plus tangent of x. I would next move all the tangents over to the left-hand side. So I'll subtract tangent of x on the right-hand side and subtract tangent of x on the left-hand side. 2 tangent of x's minus a tangent of x leaves us with 1 tangent of x. Bring down the plus 6 equals 5. And then as we have a positive tangent of x and we're subtracting a tangent of x away, that makes 0 tangent of x's on the right-hand side. We'll finish this up and move the 6 over to the right-hand side by subtracting it. That'll leave us with tangent of x equals -1. As you can see, very, very similar thought process and steps on both of these equations. Now that we've isolated the tangent of x, next what we want to do is figure out what value do we need to plug in, which angle do we plug in for x that's going to produce a -1. So this can be a little bit challenging, but +1 turns out being one of these angles that, these trigonometric ratios, I should say, that shows up quite often. So I'm visualizing to myself, I'm going to designate it with x bar, visualizing as a reference angle. If I were to plug in a pi/4 in for my x, that would produce a +1 as opposed to this -1. But +1 is one of those ratios that shows up a whole lot. So the next thing I would do is go ahead and use pi/4 as a reference angle. And I want to kind of visualize which quadrants am I going to get a negative value coming out for tangent. So I use the phrase, all students take calculus, as a reminder on this, where all of our trig ratios are positive in the first quadrant, only sine is positive in the second quadrant, tangent in the third, and cosine in the fourth. So what that kind of tells us is tangent's going to be negative in the second quadrant. So I'm going to place pi/4 as a reference angle to the x-axis in the second quadrant. And our goal is, let's go ahead and calculate which angle ends up in the second quadrant that's going to have pi/4 as its reference angle. So to do this calculation, to find that x, what I like to do is I'm going to say it's pi to go all the way around, halfway around the circle. And I want to subtract away that reference angle, the pi/4. So with a little bit of simplifying down, we'll get a common denominator. So think 4 pi/4. That's equivalent to our 1 pi up above minus pi/4 is going to give us 3 pi/4. Now, if we wanted to represent all of the exact solutions, one way to do that is we could add to the end of this plus the period of tangent, which is going to be pi, multiplied by k, where k is some integer. All right, so like 0, 1, 2, 3, 4, or -1, -2, -3, all of those values could be plugged in for k and get additional solutions to our equation. So all of this 3/4 plus pi times k would be all solutions. In our case, we are looking for only the solutions for x between 0 and 2 pi. So we have two different alternative ways to do this. You could use this pi over 4 we located up above. We could place that in the fourth quadrant where only cosine's positive, therefore tangent's going to be negative. Or you could use the solution we just came up with, the 3/4 plus pi times k, and we could use k equals 1. What that's going to do is go an extra period of tangent around, halfway around the circle, and it's going to find the angle in the fourth quadrant for us. So let's do the plugging in 1. So we can say that's 3/4 pi plus pi times 1, which could be rewritten as 3/4 pi plus 4 pi over 4, right? 4 over 4 is equivalent to this 1. And then simplifying down with that common denominator, we can say 7 pi over 4, keeping the common denominator and combining our numerators together. 7 pi over 4 still fits. It's a little bit smaller than 2 pi. That's going to be the angle in the fourth quadrant. It would also give us a solution on this one. So our two solutions in this case are 3 pi over 4 from the second quadrant and 7 pi over 4 from the fourth quadrant. If you needed all solutions and it wasn't limited between 0 and 2 pi, you could write that out as 3 pi over 4 plus pi times k. All right, hope this helps out as you're working on solving trigonometric equations. Good luck.